The tan of x is sine of x divided by cos of x. We know that the coordinates of a point on a unit circle are given by cos of x comma sine of x, where x is this angle here, measured anti-clockwise from the positive x-axis. So basically we're taking the y value of this point and dividing by the x value of this point here. So to get the tan of 44.13 degrees, we take 0.7, the y value of this point, and divide by 0.72. And you see that to 2 decimal places we get 0.97. So this red point is a point on the graph of y equals tan of x, where angle x is given in radians, 0.77 radians, and tan of x is given to 2 decimal places. So we can see what's happening to this ratio as x increases. Well, obviously this ratio is getting larger and larger because the sine of x is increasing. It's increasing towards +1 actually, but the cos of x is decreasing to 0. So the x value of this point is going to 0, but the y value is increasing to 1. So eventually we're going to get division by 0 here, which is undefined. So this ratio is approaching positive infinity as x approaches 90 degrees or pi over 2 radians. So I'll show the trace of that. So as x increases from 0 to 90 degrees or pi over 2 radians, we can see that the function is heading towards plus infinity. Now what happens as we increase x beyond 90 degrees? Well, sine over cos is now 0.95 divided by minus 0.31, so the tan is now negative. So we've jumped from positive infinity down to negative infinity at x equals pi over 2. And we can see this functions approaching pi as x approaches 180 degrees. So the function is positive for angles in the A quadrant, that is angles between 0 and 90 degrees. Then it's negative for angles between 90 and 180 degrees because we're in the S quadrant. So it's negative for x ranging from pi over 2 to pi radians. But at pi over 2 radians or 90 degrees we get division by 0. So the function is undefined there. For angles greater than pi over 2 or just slightly greater than pi over 2, we get very large negative values for the tan function. Actually there's a jump or a break here. The function goes from plus infinity to minus infinity at 90 degrees. We have what's called a vertical asymptote at 90 degrees. So we can indicate this by a dotted line. So the graph approaches this dotted line as x approaches pi over 2 from the left and as x approaches pi over 2 from the right. But of course the graph never crosses this line, so we can think of it as a boundary line. Now let's look at values of x between 180 and 270. Well, at 180 we have that the tan is 0 because we have sine over cos 0 divided by minus 1 is 0. Notice that the tan function is positive here. We're dividing two negative values and it's going to keep on increasing towards plus infinity as x approaches 270 degrees. We can see that we're approaching division by 0 in this ratio here. Notice that we're going to be switching to negative values now as we increase x. So we're in the C quadrant, so the tan function is negative, so the graph is below the x-axis. we're dividing a negative value by a positive value. Sine over cos is negative. The tan of 360 is the same as the tan of 0. That's 0. So we have another vertical asymptote here at 3 pi over 2 radians. Now, the period of a function is the smallest interval over which the function repeats itself. In this case, the period is pi. So this interval here, 0 to this point here. So you can see that from pi to 2 pi we get the same pattern as we did from 0 to pi. Now I can't show the graph for values of x greater than 2 pi because for this particular unit circle I'm only showing values of x going from 0 to 2 pi, and then the function drops back down to 0 again. But of course you can imagine what's going to happen. We just get a repeat of this pattern. Now the range is from minus infinity to plus infinity. The tan function approaches minus infinity as x approaches pi over 2 from above, or from the right. And tan of x approaches positive infinity as x approaches pi over 2 from below, or from the left.